Hi, today's lesson is on equations. An equation is a mathematical statement which has an equal to sign. So the simplest equation I can think of is 1 equal to 1. This is obviously true because the left hand side is 1 and the right hand side is 1. Another obvious equation is x equal to 3. This just says that the left hand side is x and the right hand side is 3 and they are equal. So this is basically assigning a value to the variable x. X is now 3. We can have more complicated equations which we need to solve. That means that it will involve variables and it won't be obvious what the value of the variables is till we do some arithmetic operations on them and obtain the value of those variables. So let's solve some really simple equations. Solve 2x equal to 7. We all know how to solve this one. If 2x is equal to 7, then if I divide both sides by 2, surely the equation still holds. So I can divide both sides by 2 and I get x is equal to 3.5. So I call this the solution of the equation. I now know what x is. How about minus 33 equal to minus 3x. Since both sides are equal in an equation, I can divide both sides by the same number and the equation still holds. In this case, I'll obviously divide by minus 3. So I divide both sides by minus 3 and I end up getting 11 is equal to x. So again, I've solved the equation because I've found the value of x. These are called linear equations because as we saw earlier, a linear expression is one which involves powers of x only up to the power 1. So it only involves the variable x and no higher power of x. Why they're called linear? Because when you draw them on a graph, you get a straight line. Here's another linear equation. As you can see, the powers of x are only up to the power 1. There's only x. There's no x square, x cube, and so on. How do I solve this one? 5 into x minus 2 is equal to 1 minus 3x. So there's a 5 into something in brackets. So let me distribute the 5 across the bracket. So I get 5 into x minus 10 is equal to 1 minus 3x. Now I have x on both sides. So I can't find out x till I isolate x to one side. So what I'll do is I'll bring the minus 3x to the other side. How do I do that? I need to add 3x to both sides. So 5x minus 10 plus 3x will equal 1 minus 3x plus 3x. Since I've added the same quantity, in this case plus 3x, to both sides of the equation still holds. Why did I add plus 3x? So that it nullifies the minus 3x. And here I can group the like terms 5x and 3x to get 8x minus 10 is equal to 1. The minus 3x and plus 3x nullified each other. Well, now I have the x's on one side, but I still have a constant minus 10 here. To get rid of it, I'll add 10 to both sides. So now my constant minus 10 is out from the left. So I get 8x equal to 11 and x is equal to 11 by 8. The last step is just dividing both sides by 8. When you solve this equation, you don't have to laboriously go through each of these steps of adding 3 to each side and adding 10 to each side. We know clever, quick ways of doing this. I just move the 10 to the other side. I just move the minus 3x to the other side. But that isn't really maths. What you're doing when you're moving something to the other side is that you're nullifying its effect. So if you have a minus 10 on the left, you add 10 to both sides. So the minus 10 plus 10 becomes 0 on the left. However, you've added 10 on the right too. So it's equivalent to having moved the minus 10 to the other side. Whenever you're confused about what action to take, remember you just do the same operation on both sides. If 3 minus x is equal to 2x minus 3, then 4x equal to. Well, to find out 4x, I certainly need to find out x. So I'll first find out x. So 3 minus x is equal to 2x minus 3. So now I won't do the adding x's and subtracting x's. I'll just use the colloquial language of moving x and moving numbers. So I'll move the minus x to the other side. So it will become 3 equal to 2x minus 3 plus x. So that becomes 3 is equal to 3x minus 3. I just group the 2x and x. Now I have a 3x minus 3 on the right. So I'll move the minus 3 to the left. So I add 3 to the left, so that this becomes 3 plus 3 is equal to 3x. 6 is equal to 3x. And dividing both sides by 3, I get x is equal to 2. Well, that's not my answer because they've asked for 4x. Be very careful about what they've asked. Just because you solved for x doesn't mean they want x. They want 4x. So 4x will end up being 8. And the answer is D. So again, this linear equation involved x's on both sides. So first I grouped the x's by bringing all the x's together on one side. And then I moved all the constants on the other side. And then I had an equation of the form 3x equal to 6. And that was easy enough to solve. I just divided by the coefficient of x. That's enough for linear equations. They're very easy to solve. Let's move on to slightly more complicated equations called quadratic equations. Recall that a quadratic expression is one which involves powers of x up to the power 2. So it involves x square, x, and maybe constants. The simplest quadratic equations are which involve only x square. X square equal to 9. So what are we looking for here? We're looking for those values of x which will make this equation true. That means which will make x square equal to 9. So for instance, suppose x was equal to 2. Would that do it? Would x square then equal 9? So would 2 square equal 9? Well, 4 is certainly not equal to 9. So x equal to 2 would not do it. What values would do it? Well, we know 3 square is 9 and we know minus 3 square is also 9. So I know my two solutions are x equal to 3 or minus 3. There are two solutions to this equation, 3 and minus 3. How about x square equal to 0? Well, again, I know there's only one solution in this case. It's 0. Because 0 square is 0. And no other number square is 0. So there's only one solution, x equal to 0. So quadratic equations of the form x square equal to something seems simple enough to solve. How about x square equal to 7? 7 is not a perfect square. So how do I find x? Well, I just call it the square root of 7. So if I say x is the square root of 7, then that's a solution. Because square root of 7 squared is 7. So square root of 7 is one solution. Another solution is obviously minus square root of 7. This is also a solution. Because minus square root of 7 square is equal to minus 1 square into square root of 7 square. Which is equal to square root of 7 square. Because minus 1 square is 1. Which is 7. So minus square root of 7 is also a solution. So it has two solutions. Plus or minus square root of 7. Remember, when I write plus or minus, I mean I'm writing two values. I mean I'm writing plus root 7 and minus root 7. So this is a shortcut way of writing two solutions. So x can be plus root 7 or minus root 7. How about x square equal to minus 4? Well, if x is a real number, then the square of a real number is always positive or 0. Because a negative number squared also gives a positive number and a positive number squared also gives a positive number. So this cannot have a solution. I cannot find a real number x whose square is minus 4. Solving equations by factoring. This is the most important concept in solving equations. Let's understand it a bit better. So let's go back to some properties of numbers. Suppose I say that I have two numbers a and b and I multiply them out and I get a product of 6. What can I say about a and b? Well, virtually nothing. because A could be 1 and B could be 6, or A could be 2 and B could be 3, or A could be 1 over 19 and B could be, well, what could B be? I can always solve it, right? I can say B is 19 into 6, or A could be 0.0746, and then I could find B. B would be 6 divided by 0.0746, and so on. So I can get an infinitely many pairs of values for A and B. If A into B is 6, then I can't say anything about A and B. However, suppose A into B is 0. Then we are in business, because if the product of two numbers is 0, then I can say something definite. One of them has to be 0. Either A must be 0 or B must be 0. It can't be that both of them are not 0, because if both of them are not 0, then their product cannot equal 0. This is the most important concept in factoring and solving equations. If a product of two numbers, that means if two factors multiply to give 0, then one of the factors have to be 0. Let's see how we can use this. So I'll do a simple example first. I'll solve x square equal to 4 using this method. Remember, I'm going to equate it to 0, so x square minus 4 equal to 0. Since I got 0 on the right, I want to factor things on the left so that a product of factors is 0. Well, this is of the form a square minus b square. It's x plus 2 into x minus 2 equal to 0. So now I have a product of two factors equal to 0. So I can conclude that either the first factor must be 0 or the second factor must be 0. If the first factor is 0, it leads to x equal to minus 2. If the second factor is 0, it leads to x equal to 2. So my two solutions to this equation are x equal to plus or minus 2. So that's the beauty of this method. Once I get the factors equal to 0, I can pull out the solutions by equating each factor to 0 in turn. Let's work with the given quadratic. Let me just change this quadratic. I'll make it x square minus 5x minus 14 equal to 0. That was a typo. So how do I factor this quadratic expression on the left? So the sum of the two numbers I'm looking for is minus 5, and the product of the two numbers I'm looking for is minus 14. Remember the sum and product method of factoring. So the two numbers will be minus 7 and 2. Minus 7 into 2 is minus 14, and minus 7 plus 2 is minus 5. So x square minus 5x minus 14 can be written as x square minus 7x plus 2x minus 14. I've just broken up the minus 5x as minus 7x plus 2x. Now the first two terms can be grouped as x into x minus 7, and the next two terms can be also grouped as 2 into x minus 7, because the right hand side stays 0. Now the two terms I have x minus 7 common, so I factor out x minus 7. The first term leaves behind an x, the second term leaves behind a 2. And I have my factorization. I have x square minus 5x minus 14 is equal to x minus 7 into x plus 2 equal to 0. Now it's easy enough to solve. The product of two factors is 0. So either x minus 7 is 0 or x plus 2 is 0, which leads to x is either 7 or x is minus 2. And we are done. We've solved this quadratic. How about this one? X square plus 8x equal to minus 16. Remember, I need 0 on the right hand side, so I'll bring the 16 to the left, and it'll become x square plus 8x plus 16 equal to 0. People may recognize the left hand side as a perfect square trinomial. It's actually x plus 4, the whole square. So I have my two factors. What are my two factors? X plus 4 and x plus 4. It's the same factor twice. And that product is 0. So either x plus 4 is equal to 0 or x plus 4 is equal to 0. That's a silly thing to write because it's the same thing again. So x must equal minus 4. So this is interesting. I have a quadratic equation, but it has only one solution, minus 4. Why is that? Because it was a perfect square equal to 0. If b minus 3 into 4 plus 2 by b is equal to 0 and b is not equal to 3, then what can b equal? So we have two factors whose product is 0. What can I conclude by that? So if the product of two factors is 0, that is if b minus 3 into 4 plus 2 by b is equal to 0, then either b minus 3 is 0 or 4 plus 2 by b is 0. That's the only way a product of two numbers can be 0. One of them must be 0. However, they've told us that b is not equal to 3. B is not equal to 3. So b minus 3 cannot equal 0. So this one is out. So it must be that this is 0. This has to be true. So 4 plus 2 by b must equal 0. So 2 by b must equal minus 4 and b must equal 2 divided by minus 4, which is minus half. So that's my solution. Answer is C. So this is a nice question. They give me a factorization and they've ruled out one factor. They've ruled out that b can be 3. So they've ruled out that b minus 3 can be 0. So it forces the other factor to be 0. And that gets me a value of b. Let fx equal to 25x cubed minus x. What is the sum of all solutions of fx equal to 3x? So fx just stands for 25x cubed minus x. And they want me to solve this equation. What is the sum of all solutions of this equation? So always look for the equation. So I'll just replace fx by 25x cubed minus x. And that's equal to 3x given. I need to solve. I need to find all the solutions of this equation and I need to find the sum of all the solutions. Fine, so first I need to solve. Well, I need to equate it to 0 as always. So let's bring the 3x on the left. That will make it 25x cubed minus 4x equal to 0. I need to factor this, but it's a cubic. It's got x to the power 3. However, if every term has x, so I can factor out x and it becomes x into 25x square minus 4 equal to 0. I've already factored it into its factors. Its factors are x and 25x square minus 4. Can I do better? Yes, I can. The 25x square minus 4 is a difference of two squares. It's 5x the whole square minus 2 the whole square. So I can factor 5x the whole square minus 2 the whole square further. It's of the form a square minus b square. When I factor it, I get a plus b into a minus b. 5x plus 2 into 5x minus 2. And of course, this entire product is 0. So now I can solve. How many solutions do you think I'll get? Well, I have three factors. The three factors are x, 5x plus 2 and 5x minus 2. And a product of factors is 0 means one of the factors must be 0. So either x must be 0 or 5x plus 2 must be 0 or 5x minus 2 must be 0. Well, this is already solved. This gives me x equal to 0. This will give me x equal to minus 2 by 5 and this will give me x equal to 2 by 5. So my three possible solutions are 0, minus 2 by 5 and 2 by 5. Question is, what is the sum of all these solutions? Well, the sum of 0, minus 2 by 5 and 2 by 5 is a grand 0. The answer is A. So the important trick here was firstly to bring everything on the left and then factor out the x. Once I factored out the x, life became easy because then I got a quadratic which also happened to be a difference of squares, so factoring it was easy. If t minus 8 is a factor of t square minus kt minus 48, then k is equal to... So here the variable is t and k is a fixed number which I have to find. And they've told me that t minus 8 is a factor. Recall how we factored quadratic equations. When we factor a quadratic expression, we are looking for a sum which is equal to the coefficient of t. So that's minus k. And looking for a product of two numbers which is equal to the constant coefficient, which is minus 48. So when we were trying to factor this, we were looking for a sum of two numbers which was equal to minus k and a product of two numbers which is equal to minus 48. And here they've given us one factor. So they've told us that one of the factors is t minus 8. So they've effectively given me one of the numbers. This can be written as t plus minus 8. So one of the numbers is minus 8. So they've given me one of the numbers is minus 8. And I have to find the other number. And they've given me the product. The product is minus 48. So that's easy. The other number must be minus 48 divided by minus 8 equal to 6. So I have the other number. The two numbers must be minus 8 and 6. And this quadratic expression must have factored as t minus 8 into t plus 6. And I need k. What's the sum of the two numbers? The sum of minus 8 plus 6 is minus 2. That means the sum is minus 2. So minus 2 is equal to minus k. So k is equal to 2. And we're done. The answer is C. Let's confirm that. So t minus 8 into t plus 6 must have been that quadratic expression. Let's open it out. That gives me t square minus 8t plus 6t minus 48. Yes, the product is turning out to be minus 48. And what's the coefficient of t? That's minus 2t. So minus k is turning out to be minus 2. So k is 2. Confirmed. The quadratic formula. What if I gave you a quadratic that wasn't easily factored? Suppose I give you a very strange quadratic, x square plus 3x minus 7. And you had to factor this quadratic expression. Since 7 is a prime, I know that the only factors are 7 and 1. And they're not going to add or subtract to give 3. So I want a sum of 3 and a product of minus 7. It's not going to happen. So my usual factoring method doesn't work. But there is a formula that will always work. It's called the completing the square method, but I won't do it here. All I'll do is give you the formula. So in general, a quadratic equation can be written as ax square plus bx plus c, which means that a is the coefficient of x square, b is the coefficient of x, and c is the constant coefficient. For example, something like 2x square minus 8x plus 1. Suppose I want to solve this quadratic equation. Suppose I want to equate it to 0 and find the solutions. So what are the solutions of ax square plus bx plus c equal to 0? That solution must be given in terms of a, b and c because those are the numbers involved. Those are the coefficients that make this quadratic equation what it is. So my solutions to the quadratic equation will be expressed in the numbers a, b and c. So whenever I need a solution to a particular quadratic equation, I'll plug in those values of a, b and c and I have my solutions. Well, the solutions are x is equal to minus b plus root of b square minus 4ac upon 2a and minus b minus root of b square minus 4ac upon 2a. These are the two solutions, x1 and x2. These are the two values of x that will make this quadratic equation true. That means that will make the left hand side of this quadratic equal to 0. Minus b plus some complicated formula under a radical sign. That complicated formula is very important. That's b square minus 4ac. And it appears with a plus sign in one of the solutions and with a minus sign in the other solution. And you divide by 2a. So that's our complete formula. So if you can't factor a quadratic, you always have this formula to fall back on. Let's use it. Solve 9x square minus 10x plus 1. So A is 9, B is minus 10 and C is 1. Remember, ax square plus bx plus c is my template of the quadratic equation. So coefficient of x square is 9, coefficient of x is minus 10 and the constant coefficient is 1. So I have a equal to 9, b equal to minus 10, c equal to 1. My formula was minus b plus or minus root of b square minus 4ac over 2a. What do I mean by plus or minus? I mean one solution you use the plus and the other solution you use the minus. So let's write that down. Minus of minus 10 plus root of b square, that's minus 10 square, minus 4 into 9 into 1 over 2 into 9. That gives me 10 plus root of 100 minus 36 over 18. That gives me 10 plus root of 64 over 18. Root of 64 is 8, so that gives me 10 plus 8 over 18. That's 1. So one solution is 1. How do I get the other solution? Well, I just change this plus to a minus. It's minus b plus root of b square minus 4ac and minus b minus root of b square minus 4. So that's solution 1. Let's call that x1. And x2 will be 10 minus root of 64 over 18, which is 10 minus 8 over 18. That's 2 over 18 or 1/9. So the other solution is 1 by 9. So the two solutions to this quadratic equation are 1 and 1 by 9. How do I check if I'm right? I plug in 1 and I should get 0. I plug in 1/9 and I should get 0. X square minus 10 is equal to x. So what's a, b and c? Well, firstly, to get a, b and c, remember I need to write it as something equal to 0. It's always ax square plus bx plus c equal to 0. So write it in the standard form of the quadratic equation. So it becomes x square minus x minus 10 equal to 0. Notice that the sum product method won't work because p is minus 10 and the factors of minus 10 are just 1 and 10 and 5 and 2. And none of those combinations add up to minus 1. So here a is equal to 1, b is equal to minus 1 and c is equal to minus 10. Let's use our formula. Formula again, minus b plus or minus root of b square minus 4ac over 2a. That becomes minus of minus 1 plus or minus 1 square minus 4 into 1 into minus 10, the whole thing over 2 into 1. This becomes 1 plus or minus 1 plus 40 over 2. This is 1 plus or minus root of 41 over 2. 41 is not a perfect square, so I'll leave root 41 as it is. Or I can use a calculator and get the number, something between 6 and 7. And my two solutions are 1 plus root 41 over 2 and 1 minus root 41 over 2. These are the two solutions to this equation. Note that we have irrational solutions. We have root of 41, which is an irrational number.